the LTS version, the latest LTS, which would be in the 10.15 series. I do not at this time recommend a Node version 11 install. There are some API compatibility problems with the Node.js standard library. You would need developer tools on your machine. So if you're on Mac OS, that would be Xcode, for example. If you were on Linux, you would do, it was a Debian distro, you'd
All right, guys, coming up, we got John O'Sullivan from Imbrex talking about Web2 users in a Web3 world, or a tale of two webs.
Oh, yeah! How's everyone doing? Good? Excellent, perfect. So my name is John O'Sullivan. Just to get a poll, how many people here are coders? Just raise your hand. Okay, I like that. How many people are here for more of the UX, UI experience kind of talk? Even better. Cool. So my name is John O'Sullivan. So just to quickly introduce myself, I work at Imbrex. I work primarily on our backend, managing our servers, kind of working with our smart contracts, and mostly our data. A little bit about me, I'm really passionate about decentralized systems, as well as how we can scale them, but also bring them to the mainstream. So getting our Web2 users into that Web3 environment. And on the side, I'm kind of dabble in blockchain and IoT and how we can kind of bring that to the mainstream. My email, Twitter, and GitHub link is there. If you'd like to check me out, go for it. So what is the problem? Well, the problem is this. In the real estate industry, as it stands, there's a lot of inefficiency when it comes to data and how we kind of take a listing once it's created and bring it to closing. And this is due to bottlenecks. Bottlenecks geographically, if you're to sell property in, let's say, New York versus in London, and the tools that you have to use for those two areas give a restriction to what data and what you can actually do with it. Transmission failures, so different ways of sending that data. If it's different, it will fail and prevent you from having accurate data. Asynchronous API calls, which can break the flow of data, giving you, again, inaccurate data. Siloed data, which we can think of like our Facebooks, our Googles and stuff, where you have silos of listing data. That data, let's say you have 123 Apple Street on Zillow, and it was updated yesterday, and then I updated this morning. It's updated on our site, but it doesn't get updated on Zillow right away. That's a problem, because a lot of people, who knows Zillow? I think we all know Zillow, right? Everyone will go to Zillow first and see, oh, this price is too high, but I lowered the price this morning to get more, more leads, and it just doesn't work out. And on top of that, we have a difference in how we standardize the data and actually transmit it with different networking protocols. So for example, an agent will have to go through either one or many of these tools just to get a listing from its creation to its settlement. They would have to go through different MLSs, different CRMs, and different ways of actually transmitting documents to get to that point where they can say, hey, here's our deal, let's close. And it's very inefficient. So to kind of better represent how this looks, I have this diagram. So as you can see here, all these different, let's call them portals, are not sharing the same information. They're actually relying on their own feed of information, which is very inaccurate. So if we were to go from, let's say, Zillow down there, and we wanted to go to like ZipLogic or like to Property Manager, we would have to manually either email the data or like send it some other way, but actually manually enter it into that system, which is inefficient and can lead to discrepancies. So what is our solution to this? Well, we need a solution that is pretty much built on top of the idea of Web3. It needs to be internationally available so that if I'm in New York, and let's say I put a listing on New York, let's say on Broadway Street, and someone in London's like, I want to buy some property in New York, they can get the most real-time data to actually go and actually move forward with the transaction on purchasing that property. So it has to be internationally available. It has to be tolerant. That's a big thing. And on top of that, it needs to be censorship resistant. As you get different types of data, certain parts of it you want to share, but certain parts people don't want to share. Like for example, on Zillow, if you've ever gone to Zillow, you'll see that certain parts of the information is hidden and restricted, which is not good, because if I wanted to go on Zillow and I wanted to get the most up-to-date information, the most accurate, I'm not getting it. It's slightly restricted. We don't want that. And on top of that, we want one source of truth, so that if I want to get sell my property in New York, and let's say I put it up for $500,000, and then I realize tomorrow I need to sell it, I'm going to knock off, a couple, let's say a couple thousand, that anyone around the world will get that update in real time and say, okay, this might seem like a more reasonable offer. So what's this look like? Well, let me go back for a second. Interoperability is kind of the key here between these systems. As you saw before, we had all these different portals that weren't really communicating with each other. So interoperability between these internal to external, and external to external systems is very important. And if we can get those systems to talk to each other, we can have a more efficient way of transacting real estate data and going from creation to settlement. On top of that, we need to think about the data itself. How many people have ever seen a real estate listing online? Who's actually gone and looked at property? What kind of surprises you? Well, let me give you a little hint. How much data there is. It's so convoluted. You have different fields that represent different things, and when you look at it kind of long term, some of these fields are kind of not important anymore. So a data standard is kind of key here. If we don't have a data standard, as we're kind of decentralizing it and sending out in real time, we're kind of breaking our system, because not everyone's going to get the same information and understand what the information represents. So with that standard comes control of your data. You want to control your data. So if we have a standard and we give you the ability to actually use that data, you have control of it. So we came up with the idea of Tegula. So Tegula is interesting. Tegula is a solution that allows you to own your data, implement a standard, but also allow it to integrate and be built into different portals. So for example, if I went on to imbrex.io or Zillow and I added a listing, if they had Tegula running in the back end, they could push that data out and have it sent to anyone who's actually running Tegula and get the most real-time data. Now, a big part of that is how do you ensure ownership? So we have Tegula, which is open source, and we have something called an owner key. Now, how the owner key works is, let's say I have a firm and I have 10 listings, and I make a deal with Zillow to say, hey, you can take in my listings and use it. I will give them my key, and that key is kind of my identity. So as they're getting a feed of data, if that key can decrypt the data correctly, then that's verification that that data is legitimate and is coming from a valid source. So how do we do this? Well, we use IPFS to store the data, we encrypt it, and then we use OrbitDB to actually store logs and actually allow that data to kind of be structured in a way where we can get real-time updates on the fly. And now the last component of this is the UPI. We generate a UPI that allows us, so a unique property identifier that allows us to know what pieces of data need to be updated in real time and what notifications have to be sent out throughout the system. So this is how it works. An agent adds their listing on imbrex. Imbrex will hold that key and allow that data to be disseminated throughout the system. Now let's say I put my data on imbrex and I then go to Zillow saying, hey, I want you to pull in my data and display it. I will then go get my key off imbrex and say, here's my key, and using the protocol you can bring in my data. So how it works is every time I want to make a change, instead of having to make a change and relying on all these other systems to pull in the data and make those changes every 24 hours, it's done instantaneous, which is very important. So let me see, I can't make this any bigger. I can't make it any bigger, so I don't know if you could read it. But so down here, the agents have their key, and what happens is the Ethereum blockchain will index the UPI. IPFS will store the attributes encrypted, and then OrbitDB will actually store the entity that is the UPI and the A UPI is a unique property identifier. It's how we represent the property. So OrbitDB will actually store it and give us a log. So when you enter in the owner key, it will actually give you a log of the real estate data. So our solution is very powerful, at least from a Web3 perspective on the back end. And now I want to kind of talk about the Web2. Real estate agents, they want to do this, but they don't want the technical part of it. It's very difficult for the real estate industry to understand the technicals, so we have to build a non-technical way of interacting with it. So that's what we did. We built a front end that is non-technical, but allows you to actually benefit with all these technologies that we built in on the back end. So this is what it looks like right now. This is our most recent release. You can go in, enter in an address, a keyword or something, and it'll look up a property and give you all the details, which are actually pulled in. We parse it, we give a unique identifier, and we push it out through Tegula so that anyone who actually wants to add a listing, they can add a listing and then give that key to someone else and have real-time updates of your data. So what did we learn? What did we learn in this process going from a Web2 audience to a Web3 application? Well, on day one, we learned really hard that MetaMask was not for everyone. We realized that we lost half our users just on MetaMask alone. So that's a really big thing you want to think about. So we're going to talk about MetaMask, wallets, gas fees in chapter 1, and then we're going to talk about kind of asynchronous systems, like what am I doing, am I done, and kind of how that affects the user's experience. So chapter 1, gas fees. So we realized from the beginning people did not want to buy ETH. We had people sign up, and then it prompted them to have a wallet address to launch a contract to represent them, their entity on the blockchain, and add listings, have UPIs, and do all that. And then we realized, well, no one really understood how to work with this, so we built a system around it. This system was the subscription model, and it was built on what we call the OWN model. And the OWN model is a bunch of owner accounts that allows us to actually sign transactions on the behalf of our owners, which are on the behalf of our users, which would be our agents, while at the same time giving our Web3 community the ability to use it as a traditional dApp. So what's this look like? So bear with me, I'll kind of explain it. So when you would sign up, you would have to launch a pseudo contract. Now this pseudo contract would allow you to actually interface with our whole suite of contracts to add properties, flag different listings, and actually modify that data through the contracts. So let's say you're an agent and you don't really want to use Web3 technologies like MetaMask. You would sign up, pay in fiat, and then what we would do is deploy the pseudo contract, and the parameters of the contract would be tweaked to where inside the owner contract, we would actually check if you're a subscriber or not, so that if you were to go onto the platform and add a listing, instead of MetaMask prompting you to set your gas price and actually send the transaction, we would send it to our backend where we would check, is this a pseudo contract that requires owner account to sign? If so, we would sign it and then send it to listing contract. Whereas if you're using it as a traditional dApp, you would just hit the add listings method. It prompt MetaMask, and you can then go to listings contract and add a listing. So this still led to some difficulties. So what was happening was we had people interacting with the platform, and because the gas prices were really high, our wait times were really long, and this led to the UI not knowing how to render certain features. So for example, if you added a listing and it took 20 minutes to confirm before it would render on the page, well, naturally an agent would be like, oh, this is broken. So they would keep trying again, and this would then cause the actual mechanism of adding a listing to break. So the buffer between the user experience and the actual backend was a little difficult to lay out. So what we did was we kind of moved gas back and thought about how can we abstract the Web3 to make it easier while providing those same features. So before, you would have to deploy a pseudo contract to interact with any of our contracts on the mainnet. You would get a confirmation email after that contract was confirmed, and then only after that you're allowed to use the site. So after that, what we did was we kind of went back to the traditional way of Web 2, where you would have your username, password, OAuth, with all your social media. But what we did was we separated everything into a transactions API, to where after you get onto the site, you have the ability to use the site as a purely Web 2 application. But if you enable the creation of a wallet on the site, then you're actually starting to utilize the powerful Web 3 features without having any barrier to entry. And what's nice is we kind of removed all the transaction tracking from the front end and moved it purely to the back end, so that if they needed to add a listing or get a token transfer, we do that on the back end, and after the fact, we then confirm with them that it happened. So there's no wait time up front. And as a result, users don't have to directly interact with ETH, which reduces our barrier of entry into the platform, but it also makes it easier for us to kind of reach a bigger community, because with real estate agents, a lot of this technology was built in the late 90s, early 2000s, so there is some catching up to do. So chapter 2, asynchronous systems. So how many people understand the idea of how you have to wait for a transaction to confirm before you can, do another transaction, because they're kind of dependent on each other? That makes sense, yeah? So what was happening was, to add a listing, like I said, it took anywhere from 5 to 20 minutes, and this was kind of problematic because our users didn't understand, transaction latency. And we went 100% decentralized off the bat. So we are actually tracking every transaction on the front end. So you would have the transaction hash just sitting inside the browser. So if someone closed the tab or restarted their computer, that transaction hash would actually disappear. So then when they would log back in, they wouldn't know if their transaction went through or if it was still pending. There was just no way of them knowing. So what did we do? We separated it out. Afterwards, we have Ethereum and the UPIs out of the user experience, and we do it in batch validation. So everything that they do on the platform, we verify on the blockchain, on the back end, after the fact, so that they can interact with it in their Web 2, in their traditional Web 2 experience, while still utilizing the features. So what's this allow us to do? Well, it allows us to build UI the traditional way, where people don't have to wait on asynchronous systems to confirm their transactions. And batching the transactions at peak times allows us to optimize how much gas we use when either doing a token transfer or sending a UPI. So in conclusion, what did we learn here? Well, we learned off the bat, users do not want to deal with gas. When you're designing a UI, you need to think how the experience of gas will be introduced, if it's introduced at all, because that will either determine if a user will come on board or not at all. And with gas, you need to think about how transactions will affect the flow of the user's experience. If transactions are required off the bat, you need to think, okay, I need a transaction and it's mandatory. How can I make that transaction experience from a UX perspective make sense, but also convey it in a way that people will understand I need to wait, and then after this, I can then continue on. So by doing this, we allowed an application that had multiple Web3 frictions to be abstracted out. We allowed more users to join the platform while still utilizing the powerful features. So these are our 2 chapters of our webs right now, but we actually have another chapter we would like to discuss, and that is escrow commons. So as we talked about how we need data to be in real time, and data needs to have some type of standard built on the ideas of Web3, this all plays into what we're going to do next, which is escrow commons. As I showed before, there's multiple ways of getting your data, putting in different portals to go from creation to closing. The idea of escrow commons is to create that baseline with our data so that we can then introduce escrow commons where we can use smart contracts, permissioning, and IPFS to actually exchange the important documents needed to make a transaction. So like kind of the legal documents, payments, and all that done in exchange through the contract so that ideally the end result will be you could have a path for real estate transactions that's fully digital from the creation to the settlement all in one place. Thank you. I'll take any questions. Yes. So what we do is when we have to process a transaction, we'll actually look at Etherscan to see what the gas price was, because before we were just using the estimation of gas pricing. So when we were deploying pseudo contracts at the beginning, it was costing anywhere from $35 to $40 just to onboard one user. Yeah. So optimization was a big thing. So now what happens is we actually look at what the current wait time is versus how much ETH it would take, and then use that to determine when we would actually send the transaction via the transaction API. We actually use ETH gas station. Cool. Oh, sorry. So I wouldn't know that right off the hand. We were charging. Yeah, we're just looking at the gas price on the fly. Cool. Yeah. So the confusing part comes when you got to look at the industry as a whole. The industry as a whole is pretty outdated. For example, there's something called the Web2 Protocol, which was first conceptualized back in 1999. And a lot of people are still using just email to send, documents and stuff. So it's more the user base and their standard of how much technology they know at the current moment. So it really comes down to that. So for us, we understand the importance of gas, but to explain that at an abstract level is a little overwhelming. So the idea is to make it as easy for them, because they don't care about gas. They don't care, and honestly, they don't really care about how the blockchain works. They just want their data to be reliable. They want it to be in real time, and all they want is that will lead to leads for them to then settle. And if this helps, that's great, but adding another layer of abstraction on top of that to explain gas and everything, they'll just say, okay, we'll go to Zillow.
It might be that because gas for some people, the user is the ordinary person, it might be like, my transaction that I control it, your user doesn't care something they already work.
Yeah, so if you could maybe later on we can rephrase gas as something else that makes more sense, that'd be optimal. But for right now, it's a really hard barrier. So what we were doing was the initial setup was enter username, not username, it was first name, last name, email, and then when they deploy their contract, we then get their pseudo contract and their MetaMask address. That allows us to know what contracts are doing what. We saw pretty substantial number of records where people would enter those first three things and then they'll just drop off the sign-off process. So it made it very clear the minute they hit what is a wall address or MetaMask, they jump shipped. And we realized that after the fact and spent 2 weeks completely removing it. So, any other questions? Yes. Right now we're residential, but we're hoping eventually to go into commercial as well. Yes? So if I hear your question right, is using the blockchain versus not using it change the users, like their ability to reach their goal, kind of? You have to speak up, I really can't. So right now, the value is that it's immutable, they have a history. Right now, they don't see that benefit right now, but the idea is to build out to where by adding the data there, we actually have a verifiable and actually a more accurate history, history of a listing as it's going through time. So right now, they don't really see the benefit, but ideally, once we actually kind of better persuade them to see what it can do, they'll actually understand the benefit of it. Does that answer your question? You want to come up because I'm having the business model? So the business model right now, like how it operates. So right now, how it operates is that we have a front-end application where people can, it's like Zillow, you can just search and everything, but the business is actually done purely with the enterprise. We bring in enterprise data, and the idea is to give them the ability to actually use what we've packaged to make it more easy to disseminate their data and actually get more leads. Because in the real estate industry, it's all about leads. That's why they go to Zillow and this. That's why they kind of blindly give their data away. Because at the end of the day, they just want a lead to make a sale for their commission. So the idea in our business right now, where it comes down to is the enterprises and how we can benefit them with their data, because that's really the foundation of everything. You can't build a house if you have a foundation that's all cracked and leaky. If we can solve the data issue, which is a huge industry problem that's plaguing I think all of the real estate industry, we can solve that, then we can build on top of that with different Web3 technologies to benefit them going forward. Okay? Yes? So right now, how we prove ownership of data is through that key. So if you have a property, and let's say you want to put your house up for sale, okay? You go onto imbrex, you get a unique key, you add your listing, and that listing is, disseminated and decentralized. The ownership is that if someone was to tie into the protocol and use any other key, that data would not decrypt and it would just not come in. So the verification is that your key, it's kind of like a private key, that verifies that you own that data because you're the one who pushed it out. That's how we're doing verification right now. Yes? Right now, that's not what we're really thinking about, but integration would probably be the biggest thing we would go for, yes. Oh yeah, it's also open source. There's a bounty for Tegula, so go check it out and see what you can do with it. Yeah, everything's open source for the Tegula Protocol, so go check it out. Yes. So right now, for dispute resolution with the data itself, hiccup like in so right now how we handle disputes is more on a case-by-case basis. For example, when we had an issue where people's listings were having issues populating or is inaccurate after a token, because once you validate a listing, you get a reward. If that reward, there was some issue with that, we do that manually for right now. Any other questions? Well, I'd like to thank you for you guys' time, and go check out Tegula. Thank you.